Hey everyone, welcome back to my channel. Today we're going to tackle a medium-level problem on LeetCode. Number of ways to assign edge weights I. This problem requires us to find the number of ways to assign weights to the edges of a tree such that the total cost is odd. We'll break down the problem, discuss the intuition behind the solution, and walk through the code step by step. So let's get started. The problem provides us with a list of edges in a tree and asks us to find the number of ways to assign weights to these edges such that the total cost is odd. The cost of a path is calculated as the sum of the weights of the edges in the path, and we can assign a weight of either 1 or 2 to each edge. We need to consider all possible assignments of weights to the edges and count the number of ways to achieve an odd total cost. To solve this problem, we need to understand that a path's cost is odd if it has an odd number of edges with weight 1. Think of it like a light switch. Every time you flip the switch, the state changes, and if you flip it an odd number of times, the state will be different from the initial state. Similarly, if a path has an odd number of edges with weight 1, the total cost will be odd. We can use this intuition to guide our solution and find the number of ways to assign weights to the edges. Our approach to solving this problem involves several steps. First, we create an adjacency list representation of the tree from the given edges. Then, we perform a breadth-first search to find the node with the maximum depth. Next, we use depth-first search to traverse the tree, starting from the root and targeting the deepest node found earlier. During the DFS traversal, we consider assigning weights of 1 or 2 to each edge and count the number of ways to achieve an odd total cost. We use modulo arithmetic to handle large result values and avoid overflow. Let's take a look at the code. We start by defining a class solution with a method edge score that takes a vector of edges and a node as input. Inside this method, we create an adjacency list representation of the tree and then call the DFS method to traverse the tree and count the number of ways to assign weights to the edges. The DFS method takes a graph, a target node, and a current node as input, and returns the number of ways to assign weights to the edges such that the total cost is odd. We use a queue to perform the breadth-first search and find the node with the maximum depth. We also define a method assign edge weights that takes a vector of edges as input and returns the number of ways to assign weights to the edges. This method creates an adjacency list representation of the tree, performs a breadth-first search to find the node with the maximum depth, and then calls the edge score method to count the number of ways to assign weights to the edges. The time complexity of our solution is O(n), where n is the number of nodes in the tree. This is because we visit each node once during the breadth-first search traversal and once during the depth-first search traversal. The space complexity is also O(n), where n is the number of nodes in the tree. This includes the space required for the adjacency list representation and the recursive call stack during the depth-first search traversal. And that's it for today's problem. I hope you guys enjoyed the solution and learned something new. If you have any questions or want to share your approach, please comment below. Don't forget to like the video, subscribe, and comment your approach below.